Okay, so that's the shapes that we're going to focus in on. One of the things that we kind of want to understand, and we'll kind of see this as we move on to each one, is that you should be able to tell which one is which by the equation, okay? If we think about how, if we saw something like this, 3x plus y equals 8, you should be able to look at this equation and tell me it's going to be a what? A line, right? Okay. If I look at this equation, you should be able to look at it and tell me it's going to be a what? Parabola. Okay. So we should be able to kind of distinguish these as we move on. Now, again, like I said, we're going to just start with circles right here. Okay. Give me the basic idea of what a circle is. Like, how do you know a circle is a circle when you look at it? Well, okay. Well, a lot of well, an ellipse never ends, right? And it goes. Oh my gosh, basic idea of a circle, guys. The center to the outside of a circle. The basic idea of a circle is that from the center of the circle and all the way around, pretend it's going to be equal distance. What is the distance called in a circle? The radius. Okay. So in a circle, you have a center and you have a radius. Okay, that's the basic idea of it. You have the center and the distance of the radius can form the circle around it. The center is actually not a part of the circle. Got it? It just helps guide to construct it. Now, if we talk about the radius is a distance, correct, from the center to the outside. We should know the distance formula. What is the distance formula? Square root. Okay. This is the distance formula. Okay. Now I'm going to take a detour because we should know this. This is something I literally went over with my freshmen like a week ago. The distance formula is derived by something we're very familiar with. Good. It's the Pythagorean theorem. So I'm going to quickly just kind of go over how it's constructed. So the shortest distance between 2 points is a straight line, right? But if it's at a diagonal, we can't like count the boxes. So another way to get the distance though is to go horizontal and then go vertical, and that forms us a right triangle. And if I want the horizontal distance, that's our x coordinate points, right? And to find that distance of the horizontal, you would subtract the x coordinate points, x2 minus x1, that gives you the horizontal. And to get you the vertical, it would be y2 minus y1. Now, this, we'll label it as D, okay? But you can see that these are sides of the triangle. And if we use the Pythagorean theorem, which I hope everybody remembers, the side squared, the length squared equals the hypotenuse squared. So what happens is you get x2 minus x1 squared plus y2 minus y1 squared, and that equals the hypotenuse squared. And if I take the square root to get d by itself, we can see how that's constructed. So in your homework tonight, what's going to happen is you're going to use this formula, the distance formula, to help calculate the radius, the center to the outside. It'll help you figure out what the radius is. Now, if we went backwards on this, the distance in the circle is considered the radius, right? The center to the outside. So if I kind of substitute in the distance for radius and go backwards a little bit, if I square both sides, we have x2 minus x1 squared, y2 minus y1 squared. That will equal the radius squared. This right here is your standard form of a circle. And what happens and where this is coming from is it's saying that this point right here is the center of a circle, okay, a point, right, center of the circle, and it's the distance to an outside point on the circle. So that's kind of where this circle formula comes from. And we see that right here, okay? Circle with a center is 0, 0, because if I add 0, it's just x, right? If I add 0, it's just y, and it's the radius squared. Over here, this is kind of what we'll be working with most of the time. But instead of x and y, it's labeled as h and k. And h and k, it says this above, but h and k are considered your center of the circle. And then your r is obviously the radius of the circle. Couple things to point out. What sign is in the binomial? Minus. Okay. So if I had like x plus 1, what would be that coordinate point part? If it was x plus 1, it would be minus 1 because it's the opposite sign. Okay, so whatever that sign is, it's the opposite. And then the radius is squared. So kind of keep that in mind as we go. So, two things, very basic for a circle. You need a center and you need that's it. If you have a center and you have a radius, you can graph this very easily and you can write an equation for this pretty easily. So if we look at number 1, it says the point on a circle, 1, -2 is on the circle, and the center is -3, 5, and we want to write the standard form of the equation, and then we're going to sketch the circle. So again, like we just said, we want a center, and we want a radius. Do I have either one of those? We have the center. We have the center, which is -3, -5. So we're missing the radius. What we're going to do is we're going to calculate the radius. How would you do that? Distance. Because, and let's look at this on the graph. If this is 1, -2, here's the center, and then -3, -5. What did I do? You just said 1 -2. Oh, okay. And then the center is -3, -5, and this is the outside. This right here is the radius, correct? Okay. But I can't count the boxes. But so how do I find that distance? By the distance formula, right? Okay. Yeah. So we use the distance formula to find what the radius is. So x2 minus x1 squared plus y2 minus y1 squared. So x2, -3 minus 1 squared plus -5 minus -2 squared. And we just clean this up. So it's going to be -4 squared plus -3 squared. That's going to give us 16 plus 9. I can't take the square root of each of these. Remember that, guys, order of operations. So it's square root of 25, which is 5. So my radius is 5. Again, I find that just by the distance. If I have the center and if I have the radius, you are set to go. All you're going to do is take what we saw right here, just like y equals mx plus b, and we plug it in. So I'm going to have a binomial squared, a binomial square. I'll have an x, I'll have a y, should be a y. And this is my x coordinate right here. So what should it be? X what? What goes in the binomial? Minus -3, which would just be what? Plus 3. And what goes after the y? Y what? Plus 5. So that's all you do. If I have the center, they just get plugged in to these binomials, and that's how you tell where your center is. And then it equals what, guys? Not 5. 5 squared, because it's r squared, which will be 25. So this is my equation right there. Now, if I was given the equation, I could pull out the center, correct? I would say -3, -5. And then I take the square root of 25, which is 5, which is the radius. So now that I have this, I'm going to go back because it said to make a sketch. This is my center right here, correct? And it said that the radius is 5. And we know that the outside of the circle is consistent. So what we're going to do is we'll go 5 units up. 1, 2, 3, 4, 5. I'll make a little mark. I'll do 5 down. 1, 2, 3, 4, 5. Make a mark. I'll go 5 to the left and the right. And the 4 points that I made should give me a decent idea of what this is going to look like. I'm not asking you to take a compass out or anything like that. All I'm asking you to do is just connect those points the best you can, bless you, as a circle. And just go through those points that you have. What was that? No. Not till after shared life. Okay. So I'm supposed to take a week and do nothing? Yeah. Questions on number 1. Mr. Gracebach wanted to give you guys a quiz next week. And I talked him out of that, yeah. So when, yeah, you think of, when we had vertex form of a parabola, or even when we did sine graphs, remember everything in that parenthesis was always the opposite? If it was like +5, it went to the left, it was -5, it went to the right. So it's that same idea because it's in parentheses. Yep. Yes. Like, this is the most opportune time. Okay. So we're going to do the same sort of thing. We're going to sketch the circle from this equation. But you can see that this equation isn't as nicely laid out as the other one. So this is what we do. And it actually goes back to the idea of completing the square. Do you remember completing the square? Okay, you guys, you got to be better at your a quick refresher. If we were solving this by completing the square, what we did is we pushed the constant over to the other side. So is x squared plus 6x equals -7. And what we did is, I usually put a box here. And what we did is we, quote, completed the square. First of all, do you remember what number goes in there? 2. Not 6. Not 36. It's 9. Do you remember? Yeah. You got this number, and this is the completing the square part. It's b over 2 squared. B in this case is 6. So it's 6 divided by 2 squared, which is 9. Why do we do that? What was the point in quotes completing the square? What does it do for us? You can factor it more specifically into a what? Not dots. PST. So the reason why we do this is because it becomes a PST. Why would this be beneficial? Because that's the format of a circle, right? Making those binomial squares. So what we're going to do is we're going to use this idea to help us format it better. Now remember, as we get to it, we got to do it to both sides. Okay, keep it consistent. So let's go back to the original problem. One thing I'll quickly point out, remember how I said at the beginning we should be able to look at equations and be like, okay, is this a linear line or a parabola or a circle? We should look at this, and do you see how it has two exponents of 2? Do you see that? Okay, 2 exponents of 2, and the coefficients on them are even. That's going to direct you to tell you it's a circle. So we'll kind of distinguish these as we go. But going back to how we kind of separate it, what I'm going to do is I'm going to group the x's together, I'll group the y's together, and I'll push that constant over to the right-hand side. And I'm going to, quote, complete the square on each of these. So what goes into that first red box? 1. And if I do it to one side, I do it to the other. What goes in the second red box? 4. So I'm going to add it to the other side as well because I want to keep it balanced. Before I move on, does everyone get where the 1 and the 4 came from? Remember how I said that was in and off time to go? This right here is b over 2 squared. This is b. Okay. Now, this right here is a what, guys, now? PST. How am I going to factor it? X minus 1 squared. It's the square root of that box, which square root of 1 is 1. And then I take the sign that's in front of the middle term and drop it down. Do you guys remember what a PST is? Yeah. Okay. Some of you don't seem as confident. What does this, write it down what you think it should be. No? X, not X, Y minus 2. Because whatever's in the box, so the 4 is in the box, correct? You take the square root of it. What's the square root of 4? 2. Okay, and then whatever sign is right here, that's the sign that goes right there. Nico, you have a question? All right, what's on the right-hand side? 9. Okay. This is the format we're looking for, right? It's 2 kind of binomials squared, and then it equals a constant. So what is the center of this? 1, 2. It's always the opposite numbers. What's the radius? 3. It's the square root. Nope, it's always the opposite. Whenever it's in parentheses, it's the opposite. Okay, before I graph this, anything you want re-explained? Yep. Yep. All right, so I'm going to plot 1, 2. That goes right here. And the radius is 3 this time, so I'm going to go 1, 2, 3 up, 1, 2, 3 down, 1, 2, 3 to the side, 1, 2, 3 over here. Connect those. Do better than I did, but connect them. All right. Number 3 is going to be exactly the same sort of thing. We're just going to go through it faster, get a little bit more practice with it. Everyone good on 2? Okay. So I'm going to rearrange it to group my x's together. Rearrange it to put my y's together. And then push that 6 over to the right side. What do I add with the x's? 9. What do I add to the y's? 1. All right, let's factor the x's. What does it become? What about the y's? Y minus 1 squared. And then on the right, we get 4. So you got to do the 9 and the 1 over the 2. Keep it balanced. All right, what's the center? 3, 1. What's the radius? No. 2. Square root. Always a square root. Constant. On the right, the 4. So this right here, this is r squared. You could get something. There's one problem in the book where the radius is like square root of like 10, but that's okay because if you take the square root and then square it, it's just going to be 10, right? The squares and the square roots. I don't think you have to graph it. It's just using it in the equation. All right. We're going to go to this x and y intercepts, and then we're going to bounce. Oh, I didn't graph it, did I? 3, 1 is over here. Radius is 2, so it's definitely a smaller circle than the other ones. And then you just connect them. I want to see the outsides on your paper really defined. Got it? Okay. I don't really care if the shape's a little lopsided, but as long as I see the points for the radius. We're just like chilling with the yardstick right now. Yeah, okay. Good. All right. Number 4 switches a little bit in the idea of we want to find the x and y intercepts. X and y intercepts. Again, algebra 1, guys. Algebra 1. If I want to find the x intercept, what do we do, Nico? Good. Plug in 0 for y. So I take the equation given, and I get x plus 2 squared plus 0 minus 1 squared equals 10. So that goes right here. And then I just kind of get x by itself. It's just a normal solve. So 0 minus 1 is negative 1. Negative 1 squared is 1. That equals 10. I subtract the 1. That's going to give us 9. I do the square root of both sides. When I do the square root of both sides, that gives me what? Plus or minus 3. Make sure you put the plus or minus. So from here, I'm going to get x plus 2 equals 3, or and I should say, x plus 2 equals negative 3. So x equals 1 or x equals negative 5. These are coordinate points, guys. So I'm going to do 1, 0, and I'm going to do negative 5, 0. So there are my x-intercepts. What would you do to find the y-intercepts? Same thing, but with x this time. So the y-intercept x being 0. So we'll do 0 plus 2 squared plus y minus 1 squared equals 10. Do you guys need a minute to catch up? No, we're good. Okay. So 2 squared is 4 plus y minus 1 squared equals 10. Subtract the 4. Get 6. Now, this one doesn't turn out nice. It's fine. We're just going to leave it as a radical. Y minus 1 equals plus or minus 6. That's going to give us 2 answers of y equals 1 plus square root of 6 and y equals 1 minus square root of 6. As a coordinate point, the 0 would be first. So 0, 1 plus square root of 6. I start writing on diagonals a lot, don't I? And then 1 minus square root of 6. All right. We got one more after this. And then we're done. So any questions on this? The last one's the last one. Next one's the last one. Yeah, I know. We're going to get through it. Okay. Everyone's good? Okay. This is the same sort of thing as 2 and 3. We just add a little bit more to it. Again, I want to point out a couple of things with this. 2 exponents of 2, they both are positives, right? But you'll notice the numbers in front, they're 4 and 4. That's okay. It tells you it's a circle if they're even, right? So 4 and 4, those are even, like not even as in even, but they're consistent, right? 4 going this way, 4 going that way, it's going to make the circle even. Yeah. Correct. That will be next week. Not today, but next week. All right, so we're going to regroup these as 4x squared plus 12x, and then 4y squared minus 24y, and it equals negative 41. All right, so I'm going to be adding something here. I'm going to be adding something here, but here's the difference. And we saw this in completing the square before, so we just got to remember. This has a coefficient in front of the x squared, right? Do you remember what you do? Factor it out. So I take a 4 out, and I have x squared, but I got to factor it for the whole thing. So x squared plus 3x. I'm still going to add in this box in here, okay? I'm going to take out a 4 as well over here, and this time I get y squared minus 6y. Again, I'm going to keep that box. All right, so I'm going to do this a little bit quicker. In this green box, what do I put in? 9/4. It's not a great number, but it's fine. It's 3 halves squared. That's where the 9/4 come from. And in this green box over here, I'm going to put in 9. So negative 6 over 2 squared. I'm going to put a 9. All right, so I'm going to do the okay. Actually, stop. What do I put in these boxes? No. Good. 9 and 36. Because of the 4 on the outside. Even though I wrote 9/4, what I'm really doing is I'm doing 4 times 9/4, which is 9. And I'm doing 4 times 9, which is 36. So it's a little trickier with those coefficients to keep them balanced. All right, so I'm going to clean this up. 4 times the quantity x plus 3 halves, the square root of what's in the box, plus 4 times the quantity y minus 3 squared, and that gives us, is it 4? Yep. With those coefficients, I'm just going to divide by 4. It's a coincidence that this one is 4 right here. Okay, it just happened. It could be any number. It could have been 16 or anything like that. All right, so I divide everything by 4. That makes it the formatting a little bit better for the circle. What's the center? Good. And the radius? 1.